So for tonight's homework, we're going to talk about how to graph basic sine and cosine functions. So first, I'm just going to give you a little recap of the basic shape of sine and cosine, which we talked about in class today when we did that activity with the fettuccine. So remember, sine of x is always the y value of the point. So if I'm on the unit circle at 0 degrees or 0 radians, then my y value is 0. So I'm going to plot my first point. I make my scale 1 and -1, so it's not too squished. At pi over 2, which is 90 degrees, I have a value of 1. At pi radians, which is 180 degrees, my y value is 0. At 3 pi over 2, my y value is -1. And then at 2 pi, or 360 degrees, my y value is 0. So now just make sure that you connect this in a nice smooth curve. I don't want straight lines. And it should almost look like a hill at first, and then a little valley or a cup that you can pour in. And that's y equals sine x. All right, for cosine of x, remember that's the x value of the point on the unit circle. So at 0 radians, we have 1. So I don't know why I just drew that at 0. Let me fix that. So we're at 1. For pi over 2 radians, our x value is 0. At pi radians, our x value is -1. At 3 pi over 2, it's 0. And 2 pi, we're back up to 1. Now, when you connect this, just be careful, because this is usually where students will kind of mess up the concavity. So first, it's like the second half of the hill going down, and then it wraps around over like this, and then back up. So it should almost look like a cup that you can fill in. And I missed getting 100 on my course 3 Regents because my cosine graph wasn't curvy enough, so I will take off points. Okay, so now we're going to take a look at graphing functions where it's a sine of bx or a cosine of bx. So it's going to have some vertical and some horizontal stretching or shrinking, but we're not going to actually shift anything until we get to class. So the amplitude is going to be how high or low it stretches, and that's equal to the value of a. And the easiest way to think about that, I was going to say the distance from like the middle of the graph to either the top or the bottom, but really it's just half the height. The frequency is equal to b, and that is how many full curves that you see in 2 pi. And then the period is going to be 2 pi over b, and that's going to be the length of one curve. All right, so let's take a look at our equation. Y equals 3 cosine of 1/2 x. So that means that my amplitude is going to be that number in the front, which is 3. My frequency, which is that b value, is going to be 1/2. So that means I'm only going to see half of a curve. And for the period, that equals 2 pi over b, so 2 pi divided by 1/2. And when I divide by 1/2, it's like multiplying by 2. So I get 4 pi. So it would normally take me 4 pi radians to see the whole entire cosine curve. So what I'll usually do is off to the side, I'll sketch a general cosine curve. And now I know that they said that we're only going to see, it would take 4 pi for the full curve to show up. So this part would happen at 2 pi. This part would happen half that, which is pi. So we're only going to be seeing half of this graph, which is this portion that I've kind of outlined in yellow. So what I'm going to do now is my first point is starting up at the amplitude, and the highest point for us, the amplitude was 3, so it's going to be 3 units above. The next point I'm going to see is going to happen at pi, and that was at 0. So notice I'm skipping over pi over 2 for now. My next point that I'm going to see is down here, and that's going to be at the negative version of the amplitude. So at 2 pi, I'm going to be down at negative 3. Now remember, this is a curve, so I don't want to see a straight line. I'm going to curve down for that first piece, and I'm going to sort of curve up, concave up for the second. And that right there is going to be my graph. Okay, so second example. Amplitude, number in the front, so my amplitude is negative 2. Frequency is the b value, that's what's over in front of the x, so it's going to be 1. So I'm only going to see one full curve. Period is equal to 2 pi over that b value, so 2 pi over the frequency. And when I simplify, I just get 2 pi. So it would take that normal amount of time. So this one isn't going to be stretched or shrunk horizontally, only vertically. So normally a sine curve would start at 0, go up, down, and then back up again. But since this was an amplitude of, we had a negative there, that means it's going to instead start the other way. So it's going to start at 0, it's going to go down, and then up. Although one thing I should note is that amplitude is really always positive because it's measuring like the height. So we can take the absolute value of that a value. So technically the amplitude is positive too. You just have to keep in mind that it's negative, so it's being reflected and it's going to start going down first instead of up. So I'm going to start at 0 radians. I'm going to be at 0. Then at pi over 2 I go down to the amplitude. So I'm going to move down 2 units. Then pi, I'm back up to 0. 3 pi over 2, I go up to 2. And then at 2 pi, I go back down to 0 again. Make sure it's curvy. And there's our graph. All right, so you're going to try number 3 and 4 on your own, and then I will check them tomorrow and give you the solution. Okay, so number 5, this is the graph that you had drawn on your paper. And since it's starting at the amplitude or the negative amplitude instead of at 0, I know it's got to be a cosine graph. So I know it's cosine. I also know it's going to be a negative cosine because of the fact that it started down in the negative side instead. So I know I'm going to have y equals negative. Now that amplitude, the height is 3 units. So I know it's going to be negative 3 cosine. And now we have to ask ourselves, how many curves do we see here? Well, I see one full curve here. And then I see a second curve here. So that means that my frequency, which is that b value, is going to equal 2 because I see 2 full curves in 2 pi. So my final equation is negative 3 cosine of 2x. All right, I'll see you in class and we'll do a little bit more advanced graphing.